Hi everyone, for today's lesson we are going to learn how to solve quadratics by completing the square. So far we have learned two different methods. We've learned how to solve quadratic equations using factoring method and square root method. For today's, we're going to be learning about completing the square. Completing the square has a strong relationship with perfect square trinomials. Remember, perfect square trinomials is where we had our first term being perfect squares. Our last term were perfect squares, more specifically, plus a perfect square. And our middle term was an even number, a special even number that was double the square root of the first term times the square root of the last term. And when we factored these perfect square trinomials, we always ended up with a parenthesis squared, in which the first term was the square root of a squared, and our last term was the square root of b squared, and the sign in between was related to the sign of b. We are going to be working with this skill a lot in the next few lessons. So this is all about perfect square trinomials. If you have not already memorized and been able to recognize perfect square trinomials at this point, make sure you start keeping your eyes peeled for working with perfect square trinomials now. We will be working with this pattern, and I need you to be proficient in understanding and recognizing it. So our warm-up for today is for you to factor each expression completely. So I'm asking you to please pause the video and complete numbers 1, 2, and 3 on your own. All right, let's go ahead and see how well you did. So the first thing that we want to do when you see n squared minus 12n plus 36 is recognize that it's a PST. The square root of n squared is n, the square root of 36 is 6, and we have a minus sign, so that's going to be minus. Let's think about this. 6 times n is 6n. 6n doubled is 12n. So yeah, that's a perfect square trinomial, and our factorization works. Let's look at number 2. This is also a perfect square trinomial. The square root of h squared is h. The square root of 4 is 2, and our b value is a positive sign. So that's going to be h plus 2 squared. Let's check this out. What's 2 times h? 2h. 2h doubled is 4h. So we know that this works out well. Let's look at number 3. This one's a little bit different because our a value is not 1 this time, but it's still a perfect square trinomial. The square root of 9 squared is 3x. Is 3, and we have the square root of 9x squared is 3x. The square root of 4 is 2. The sign of b is minus. Let's check this out. What is 2 times 3? 6. What's 6 doubled? 12. So that is the pattern of perfect square trinomials. And what's really cool is that if you have a perfect square trinomial on one side of your equation, you can rewrite that side in factored form as a quantity squared and then use square roots in order to solve. So like in example number 1, we have x squared plus 6x plus 9. This entire trinomial, that's a PST. And the way that we're going to factor it is with a parenthesis squared. We'll still make it equal to 36, but the square root of x squared, that's x. And the square root of 9, that's 3. The sign in the middle is a plus sign, so we have x plus 3 squared. Now remember that whenever you have a quantity squared, we can use square roots, which would mean we would take the square root of one side and the square root of the other, and we would end up with x plus 3 is equal to, and that's because the square eliminates the square root, we'd leave with x plus 3 equals plus or minus 6. And it's going to be plus or minus 6 because we are taking the even root. This is a quadratic equation. You always have to keep in mind that there might be two solutions, two locations on a quadratic function that crosses the x-axis, because we're always trying to identify what those x-intercepts are, those solutions, those roots They all mean the same exact thing. So now I'm going to subtract 3 on both sides. And when I do that, the way that you write this is it's going to be x equals negative 3 plus or minus 6. Now, because 6 doesn't have a root and it's a normal number, the expectation is that you're going to separate this into two pieces. X equals negative 3 plus 6 or x equals negative 3 minus 6. There's two things going on here. And because the number 6 doesn't have a radical, doesn't have an I, it doesn't have anything like that, you should and need to separate. The answer is going to be x equals 3 or x equals negative 9. Let's look at number 2. For problem number 2, we have a perfect square trinomial. On one side, 16x squared minus 8x plus 1. So because this side is a perfect square trinomial, instead of making this equation equal to 0 like we normally would, strategically it makes more sense for us to simply break this down into a parenthesis squared equals 9. This is only a strategy if one side of the equation is a perfect square trinomial. This is the only reason why you wouldn't make it equal to 0. So now I'm going to take the square root of 16x squared, that's going to be 4x, the square root of 1 is 1, and the sign of b is minus. So 4x minus 1. We're now going to take the square root of both sides, and when we do that, we end up with 4x minus 1 equals plus or minus 3. I need to get x alone, so I'm going to add 1 to both sides. When I write that down, I know it's going to be weird, but the plus or minus piece always goes second. It's going to be 4x equals 1 plus or minus 3. And now I'm going to divide both sides by 4. So I end up with x is equal to 1 plus or minus 3 over 4. Because there are no roots, no radicals, no i's, no nothing like that, the expectation is that you're going to separate this into two pieces. X equals 1 plus 3 divided by 4. Or x equals 1 minus 3 divided by 4. Now, some people can do this in their head, and I'm perfectly fine with that as long as you're showing me appropriate steps, at least going from here and then what your answers are. I'm cool with that. 1 plus 3 is 4. 4 over 4 is 1. 1 minus 3 is negative 2. Negative 2 over 4 is negative 1/2. So your solutions are x equals 1 or x equals negative 1/2. Now this is really cool and all if you already have one side of your equation being a perfect square trinomial. That's great. That's really nice, Miss Olivero. But what if the other side is not a perfect square trinomial? What do? Well, we're going to create one. And that is the method of solving by completing the square. What we'll need to do is we'll need to find a constant value that we're going to call C that makes a perfect square trinomial. That's what we will need to find. We'll need to identify a new C. So that value of C is going to be equal to our B value divided by 2 and then squared. That's going to be our new C. And to find the value of C, or the new C, that makes the expression a perfect square trinomial, you'll need to identify this value. Then you'll write the expression as a square of a binomial. So, once again, the formula to find C is you take your B value, cut it in half, and then square it. Think about it. Well, in all of these problems right here, I have x squared minus 26x plus C. What would our C value be? Well, our B value is negative 26. We would cut it in half and then square it. So half of 26 is negative 13, and negative 13 squared is 169. So if this was x squared minus 26x plus 169, that's a perfect square trinomial, where our first term is a perfect square, our last term is a positive perfect square, and our middle term is a very special even number. So therefore, it's going to be x minus 13 squared. So what we're going to do is we're going to have two terms of x squared and a bx. And then we need to find what our c value is. And the way to find that c value is to take your b value, cut it in half, and square it. That's the pattern. I would like you guys to please go ahead and complete that solo question on your own. Please pause the video at this time. And I want you to please try this one on your own. All right, let's go ahead and see how well you did. So if we need to find a new c value, our c value needs to be our b value, which is 14, cut in half and squared. Half of 14 is 7, and 7 squared is 49. So our trinomial needs to be x squared plus 14x plus 49. First term and the last term are perfect squares. The last term is a positive perfect square. Our middle term is an even number, a very special even number. When I say special even number, what I'm trying to say is that if we took 7, multiplied it by x, and doubled it, it should end up with our b value. 7 times x is 7x. 7 times 2 is 14. So that's why I say that it's a special even number, because it falls into our pattern. Now, completing the square can be used to solve any quadratic equation. It might not necessarily be the most appropriate, but it can be used to solve any quadratic equation. So the ones that are not factorable, we can solve them now. The ones where you have just an x squared, maybe you still want to just stick with square roots. But all the other ones, like where factoring is inappropriate and you cannot factor it, well, now you can solve those equations using completing the square. Now, you can use completing the square to solve any quadratic equation by transforming the equation into x squared plus bx equals c. And then you would use the complete the square process, meaning you would find a new c. The thing that you need to make sure, like in our example 3 in our solo, the thing that they had in common was that the a value was 1 and we had just our b value. You really want to make sure that that leading coefficient is 1. So you may have to divide or factor out a number in order to make sure that the leading coefficient in front of x squared is the number 1. Then you'll want to move your constant to the other side so that you are left with x squared plus bx on one side of the equation. And then we'll need to find our new c and add that value, that new c value, to both sides of the equation. You'll factor into x squared plus b over 2 squared, and then you'll continue to solve using square roots as normal. So let me go ahead and repeat this again. In example 4, what's really nice about it is that it's already set up into x squared plus bx equals a number. Please follow along with every single step that I do. Please do not skip any steps. The first thing that you want to do is rewrite this equation into x squared plus 20x plus, I'm going to put down a finger of space, equals negative 19 plus a finger of space. And this space right here is for our new c value. Now, I have space for a new c because whatever you do to one side of an equation, you have to do to the other side of the equation. So now I'm going to find what my new c value is. My c value is equal to my b value, which is 20, cut in half and then squared. Half of 20 is 10. 10 squared is equal to 100. So my new c value needs to be 100. And whatever you do to one side, you do to the other. So I add 100 to both sides. Next, I now have a perfect square trinomial. So right here, x squared plus 100 plus 20x plus 100, that's a perfect square trinomial. And so we are going to factor and rewrite this in factored form as a parenthesis squared. So this is going to be x plus the square root of 100 is 10. And it's plus because that b value is a plus. This is going to be equal to, I'm going to combine my like terms on the other side, and 100 minus 19 is 81. Now, it's just like the problems that we had before at the very beginning of this lesson. We're going to take the square root of both sides, and we end up with x plus 10 is equal to plus or minus the square root of 81 is 9. So now I'm going to subtract 10 on both sides, and I end up with x is equal to negative 10 plus or minus 9. Now remember, though, plus or minus always goes second. So we separate this into two separate equations. This is x is equal to negative 10 plus 9, in which that is going to be equal to negative 1. Or we have x is equal to negative 10 minus 9, in which x is going to be equal to negative 19. So our two solutions are negative 1 and negative 19. Let's go ahead and look at number 5. What's nice about number 5 is that our a value is 1, but I need to come up with a new c value. So I have a c value here. It's a beautiful c value of the number 1. It is a perfect square, but that even number of 10, well, this is unfortunately not a perfect square trinomial. And that's because, 1 times 2 doesn't equal 10. So in this case, it's not going to work. We need to come up with a new c value. So I'm going to start off by subtracting 1 on both sides, and I'm going to rewrite this as x squared minus 10x plus, I'm going to leave space for a new c, is equal to negative 1 plus space for a new c. And I know it sounds kind of ridiculous to write these lines right here, but if you don't write those lines, a lot of kids will forget to leave that space. So you need to make sure that you have space available and intentional with your work so that you know what you're going to be adding in each spot. Now to find my new c value, that's going to be my b value, which is negative 10 cut in half and squared. Half of negative 10 is negative 5. Negative 5 squared is 25. So I need to add 25 to both sides, and eventually you won't have to show this work. You'll be able to see what that value is going to be without having to write anything. But what's really nice is that because we added 25 to both sides, we now have one side that is a PST. And what's nice about it being a PST is I can now write this side of the equation as a parenthesis squared. More specifically, x minus 5 squared. This is going to be equal to negative 1 plus 25, which is 24. Now that I have a parenthesis squared equals a number, I'm going to simply take the square root of both sides. And I end up with x minus 5 is equal to plus or minus. Because this is 24, we can simplify it and write it in simplified radical form. That is the expectation always. And so, unless we are dealing with contextual questions, and we'll deal with that later on. Anyway, so this is going to be, well, I know that this is 4 times 6, so so this side is going to be 2 plus or minus 2 square roots of 6. I'm now going to add 5 to both sides, and when I do that, I end up with x equals 5 plus or minus 2 square roots of 6. And because it has a root, we don't really separate it into two pieces like we would if they were all integers. So we simply leave our answer as you guys see. Number 6 is a big old mess. It's just an absolute mess because our a value isn't 1, and we have a c value that even though it's 100, that's great and all, our a value isn't 1. So this is not a perfect square trinomial. We need to figure some things out. So this is what I would recommend doing. First, subtract 100 on the other side. Get it into that form of ax plus b. We end up with 3x squared minus 36x is equal to negative 150. Because this is an equation, what you can do is you can divide every single term by 3. And the reason I'm going to do that is because I need that first term to be a positive 1 in order for me to complete the square. So this is now x squared minus 12x plus space for a new c equals negative 50 plus space for a new c value. Well, we already did this problem. At least I think we did. Yeah, up in number 1 where we have n squared minus 12n. But to show that work for new c, that's going to be your b value cut in half and then squared. Half of negative 12 is negative 6. Negative 6 squared is 36. So we are going to add 36 to both sides. We now have ourselves a PST. So that's going to be a parenthesis squared. Inside of that parenthesis is x minus 6. And that's going to be equal to negative 50 plus 36, which is negative 14. I am now going to take the square root of both sides so that I can get rid of that square. And I end up with x minus 6 is equal to, well, plus or minus. And because it has a negative, that means that I'll have an I on the outside of this radical, I square roots of 14. I'm now going to add 6 to both sides, and I end up with x equals 6 plus or minus I square roots of 14. Nowhere in the directions did I say that we have to work with only real numbers, so therefore this is our valid answer. All right, I'm going to go ahead and flip the page. The next 2 problems are solo questions that we are going to be discussing in class. Please feel free to work on them before coming to class. If you want to simply wait, I completely understand as well. So, long story short, when it comes to completing the square, there's a few things that you need to know. First of all, completing the square method is most appropriate because that's going to be a question that you'll see. When is it most appropriate to use completing the square? Completing the square is most appropriate to use when the equation cannot be factored. So if the equation can be factored, you shouldn't use it. You should always do factoring first if it is factorable. Number 2, the equation is already in x squared plus bx equals c form. If it's already in that form, it makes sense to use completing the square. If it's not in that form, use a different method. Number 3, the a value is 1. It's already 1. And number 4, when the b value is even. So an example of each type is something that I'm going to be asking you guys to write down. This is also going to be a solo. Write an equation not provided in your notes. Bless you. Do not write something that we've already given you. Come up with your own equation that is most appropriate to solve using each of the methods that I've already taught you. Factoring, square roots, and completing the square. So that is going to be your solo question. And we also have a pair question. Compare your equations with the people in your group and then discuss why your equations are most appropriate. So this is something that you will do on your own and then you will compare. We have one more example and then we will have a solo question for you guys to do as well that's pertaining to the application of solving by completing the square. So in example number 7, it says the area of the triangle shown is 20 centimeters or 20 square centimeters. We want to find the base and the height of the triangle. So remember that the area of a triangle is equal to base times height divided by 2, or 1/2 base times height. In this problem we have 20 is equal to my base, or I'm going to go 1/2 times my base, which is x plus 2, times my height, which is 1/2 x. Okay. What I'm going to do first is I'm going to start off by cleaning this or multiplying this out, I think I'm going to make this 1/2 and this 1/2 that's on the outside, make it 1/4. So I'm going to make this 20 is equal to 1/4 x times x plus 2, just to kind of make it look a little bit easier. Here's a trick. If you ever see a fraction in an equation and you want to get rid of it right away, the first thing you need to do is multiply both entire sides by that common denominator. And in this case, the common denominator is 4. So I'm going to multiply both sides by 4. What's going to happen is that I end up with 80 is equal to, the multiplication and division of 4 cancel away, leaving us with x times x plus 2. So now I have 80 is equal to x squared plus 2x. Look at that. I have my a value is 1 plus a bx. And now what I need to do is I need to add a new c value to both sides. My new c value is going to be equal to my b value, which is 2, cut in half, and then squared. And we know that 1 squared is equal to 1. So I'm going to add 1 to both sides. We now end up with 81 is equal to x plus 1 squared. And that's because x squared plus 2x plus 1, that's a PST. I am now going to take the square root of both sides, and I end up with plus or minus 9 is equal to x plus 1, because the square eliminates the square root. I'm going to subtract 1 on both sides, so they find that x is equal to -1 plus or minus 9. So the answer is either -1 plus 9 or -1 minus 9. So x is going to be equal to 8 or x is going to be equal to -10. Now let's be real. We're talking about base and height and the area of a triangle. So our negative value does not make any sense in this problem. X equals 8 makes more sense. So we're going to work with x equals 8. Cool. That doesn't answer the question. The question is asking us to find the base and the height. That's what it's asking us to find. So our base, that was equal to x plus 2, so that's 8 plus 2, which is 10 centimeters. And our height, that was equal to 1/2 times x, so that's 1/2 times 8, which is 4 centimeters. And we were able to identify the base and height of this triangle using completing the square method. The next question is a solo question that you're welcome to get started on it now, or you can talk about it when we get together in class. That is the end of today's lesson. If you have any questions over anything pertaining to completing the square, please make sure that you email me. Otherwise, I hope you have a wonderful day.